All right. Apparently my last video got messed up and I had to splice these two videos together. Back to this. Identifying each of the following functions as even, odd, or neither. So I've got my first function, f of x equals x squared plus 6. I'm going to evaluate this function at f of the opposite of x. Now my original function is x squared plus 6. So I'm going to leave a space and put the negative x squared in there so that I can evaluate f of the opposite of x. So f of the opposite of x, now when I square a negative, it goes positive, plus 6. And now I'm looking and comparing this on the right side of the equal signs. They're exactly the same. Nothing changed. So when I evaluate f of x at f of the opposite of x and I get the same output, the function is even. So we'll say, since f of the opposite of x is exactly equal to f of x for all x in the domain of f, the function is even. The next one, we're going to do the same thing. We're just going to take each one of these functions and evaluate at f of the opposite of x and compare the output. So here, this is a g function, so I'm going to evaluate g of the opposite of x. I'm going to set it up. The original is 7x. I'll leave a space, for the x. And then I'm going to substitute the negative x inside. And now I'm going to actually simplify this. G of the opposite of x equals, well, when I cube a negative, it stays negative. So this is negative 7 times x to the power of 3. And then here is the opposite of a negative. That's positive, plus x. You can compare it here, when I look, g of x and g of the opposite of x. 7x cubed, this is negative 7x cubed, this is negative x, this is positive x. So when all of them have opposite signs, that means it was changed. And in fact, I'm going to rewrite it like this and factor out that negative. So I get a 7x cubed subtract x. Now if I look here, 7x cubed subtract x is inside my group, but there's a negative outside. All right, so again, I'm comparing these. You could either do it here at this step or here. If you do it at this step, you have to make sure all the signs changed. All of them became opposites of what you had in the original. Or factor out the negative and do a comparison. This and this is the same, and here's where the opposite happens. But the bottom line is since g of the opposite of x is equal to the opposite of g of x, the function is odd. All right, move my paper over a little bit. All right, so one more time, up here. I compared the two, the output, right? The output is the y. F of x takes the place of y. All right, so I compare the right side, x squared plus, it's exactly the same. So since f of the opposite of x equals f of x, the function is even. Folks, we're saying that when the x's are opposites, the y's are still going to be the same. And that's true with an even function. And since g of the opposite of x equals the opposite of g of x, then the function is odd. So what's really happening here is when the x's have opposite signs, so do the y's, right? Because, g of x really is y. So this would be y equals negative y. And if we look back on our cube function that we did above on the top of the notes, and we look at these ordered pairs, this is an odd function. This is the function f of x equals x to the power of 3. It's an odd function. And I'm going to tell you the easy way of how you can tell just by looking at the equation if the function is even or odd. I'm going to go over that in a few moments. But up here and here, if I look, when the x's are opposites, so are the y's. Okay, so here I have 2 and -2 and 8 and -8. So when both the x's and the y's are opposites, then the function is odd. And that's what we are, excuse me, talking about here. When the x's are opposites and the y's are the same, function's even. When the x's are opposites and the y's are opposites, the function's odd. The last one is going to be a situation where neither thing is true, which you should expect. Because we did the even, then we did the odd, and then we're going to do the neither. So I'm going to arrow down here. I'm going to evaluate h of the opposite of x. I'm going to set up my template, x to the 5th plus 1. I'm going to substitute the opposite of x in there. And now I'm going to simplify this. A negative raised to an odd power is still negative, so that's negative x to the power of 5. This one does not change. So, h of the opposite of x equals this. Folks, we're comparing h of x and h of the opposite of x. Are they the same? Well, no, the one is the same sign, but the x term changed signs. If I were to take it a step further and factor out that negative, that would be positive x to the power of 5 minus 1. It's still not the opposite. It's just not, because this part now, x to the power of 5 plus 1, is now x to the power of 5 minus 1. So they're not the same and they're not opposite. Okay, because this is not the same and this is not the opposite of that. So this is a situation where neither, since we'll say h of the opposite of x is not h of x or the opposite of h of x. All right? Neither condition is true. The function is neither even nor odd. Okay, so that's a neither situation, because when I evaluated function at h of the opposite of x, I didn't get the same output, and I certainly did not when I compared these. I didn't get the opposite output either. All right, this is how you would do this algebraically. Now, I am going to show you a shortcut, and you may use the shortcut on a test or a quiz, but you have to show the work for the shortcut on a test or a quiz. Do not use the shortcut if you don't understand the shortcut. So what I'm going to do in the margin over here is I'm going to recopy the f of x equals x squared plus 6. The g of x equals 7x cubed, subtract x, and the h of x equals x to the power of 5 plus 1. Now, what you need to understand and be able to remember to do here is that every term in your polynomial has to have a variable. All right, so this is a quadratic term and this is a constant. It doesn't have a variable. But I can put a variable in there. If I insert an x here, that's my variable. But it can't be x to the power of 1 because x squared plus 6 is not the same as x squared plus 6x. So I need some exponent on x that's not going to change this number from being a 6 originally. Well, 6 times 1 is 6, and x to the power of 0 is 1. And so that's how I can trick it. All right, so this becomes x squared plus 6 times x to the power of 0. this has an x. It doesn't have the exponent there, but you could write it. Write the 1. And this here, I have x to the power of 5 plus 1. Again, this is a constant. So for each time you have a constant term, you want to insert an x to the power of 0 right next to it. All right, so momentarily I'm going to show you the trick of how to show if a function by looking at its equation is an odd, even, or neither odd nor even function is by just by looking at their exponents. But there's one thing that you have to understand. Okay, 0 is a very strange number. Really easy to work with, difficult to understand. It's smack dab in the middle of the number line separating my negatives and my positives. So why doesn't 0 have a sign? I don't know. That's a property that's kind of out there as well. All right. Well, I mean, there's a philosophical reason, but you would have to investigate that. It's long, it's drawn out. The very easy thing saying is I got nothing, so I don't have one and I don't owe one. I got nothing. Okay, so we could think of it in terms of that with the signs. But what you have to be willing to accept is that 0 is an even number. I mean, just for the very fact that it is sandwiched in between two odds. And on the number line, every other number, it switches. Even, odd, even, odd, even, odd, right? -3 is odd. -2 is even. Then this is odd. That's even. Odd, even, odd. So 0, convince yourself or memorize, 0 is even. It's between two odds. All right, so now that you know that and you've got that, we're back to this. Just look at the exponents now. And you can do this on a test or a quiz. Learn the quick, short way. But you'll have to show me work, and the work is what I'm going to show you in a moment. You could do this way, the algebraic way. But I'm going to do it this way. So I look and I say all of my terms in the polynomial have to have a variable. And if it's a constant, I'm going to put an x to the power of 0 there. Now I'm going to look at all of the exponents, all of the powers on the exponents. 2, that's an even number. 0, that's also an even number. And if all the exponents are even, the function is even. This would be the work that I would be requiring you to show me on a test or a quiz. All right, so since all of the exponents are even, the function's even. And we saw that here. The function was even. All right, the next one. I'm looking at the exponents. This one had a variable. I just couldn't physically see the exponent, so I wrote the 1. The 3 is odd. The 1 is odd. If all of the exponents on the variables are odd, then the function is odd. And lastly, I'm looking at this last example again. There was a constant, so I had to slide in an x to the 0 power here. This exponent is odd. This exponent is even. Folks, we can't be even and odd at the same time. So the function is neither even nor odd. So, if you like the easy way, learn how to show the work the easy way. Remember that you have to slide in an x to the 0 power there. And then, compare the exponents. Well, look at the exponents and determine if they're even or odd. So, this would be enough work to show me that I know you know function is even, odd, or neither. All right, that ends this part of the section. If you have any questions, you know what to do. Contact me somehow, whether you're in class or on the homework discussion or in a Google Meet. Have a great day.